Hey everyone, and welcome. Today, we're going to pull back the curtain on Docker. It's that incredible tool that finally solves one of the oldest, most annoying problems in the tech world. That classic excuse, well, it works on my machine. We're going to see how it makes sure your code runs exactly the same every single time, no matter where it is. So let's start right there with that universal problem. It's an issue that has probably caused more gray hairs for developers and project managers than any other bug in history. Oh man, you've heard this before, right? It works on my machine. It's the phrase that signals a long, frustrating day ahead. It's the root of so much confusion. And it's the exact reason Docker was created in the first place, to make this phrase obsolete. To really get a feel for this, let's forget about code for a second and think about cake. Imagine you've spent weeks, maybe even months, perfecting a recipe for the most amazing chocolate cake, and now you want to share it with the world. So you write everything down with extreme care. I mean, every single ingredient, down to the gram, the precise oven temperature, the exact mixing times, every single step. On paper, it is absolutely flawless. But here's where it all goes wrong. Your friend's oven runs a little hot. Another friend uses a different brand of flour that's just slightly different. Someone else's measuring cups aren't quite accurate. See, every kitchen is its own unique environment, just like every developer's computer. And the result? 95% of the time, the cake just doesn't come out right. It's dry, it's dense, it's a disaster. And that is exactly what happens with software. A piece of code that runs perfectly on one laptop breaks on another because of tiny, invisible differences in their setup. So how in the world does Docker solve this culinary catastrophe? Well, it basically gives everyone the exact same standardized kitchen to make in. Let's introduce the core idea here with another quick analogy. All right, picture your computer as one of those giant, messy toy boxes from when you were a kid. You got all your different apps and programs, they're like different toys, just thrown in there together, it's total chaos. Now Docker comes along and it's like a professional organizer. It gives you these perfectly neat, separate, smaller boxes for each type of toy. Your Legos go in this box, your action figures go in that one, and the race cars get their own. Nothing gets mixed up. And this right here is the key: isolation. Every application gets to live in its own little world, its own self-contained environment. And the best part? It's incredibly lightweight. Unlike a whole virtual machine that has to pretend to be an entire computer, a container is smart. It shares the core parts of your main operating system, which means it can start up in seconds and uses way, way fewer resources. Okay, so we've got the big idea. Now let's get into the nitty-gritty and see how this all works. We're going to translate our analogies into the three core pieces that make Docker tick. First up, everything begins with what's called a Dockerfile. This is, quite literally, the recipe. It's just a simple text file where you write down every single command and instruction needed to build the perfect, pristine environment for your app to run in. When you follow that recipe, you create a Docker image. Think of this as the finished, vacuum-sealed, ready-to-bake cake mix. It's a perfect snapshot, a template that has everything your app needs to run: the code, all the tools, all the libraries, all bundled up together. And finally, you take that image and you launch a Docker container. This is it. This is the magic box in action. It's a live, running version of your application, completely isolated and totally consistent, no matter whose computer it's running on. Okay, this all sounds really cool in theory, right? But what does this actually look like for a developer? How do they use this stuff day to day? Well, the workflow is actually pretty simple and repeatable. First, you write the Docker file. That's your recipe. Then you run a command, docker build, and that creates the image, the package. Next, use docker run to bring that image to life as a running container. And finally, when you're ready to share, you use docker push to send it up to a shared library for your whole team to use. And that sharing part? That often happens on a place called Docker Hub. The best way to think of it is like a giant public library, or maybe an app store, but for Docker images. Developers can upload their own creations, or they can download thousands of pre-built images for common things, like databases or web servers. It's a huge time saver. So now we understand the what and the how, but let's talk about the why. Why has this whole container idea become such a massive deal? What's the real-world impact that turned this into an industry standard? Well, the benefits are just enormous. That portability you talked about, it finally kills the "it works on my machine" problem for good. The isolation is huge for security and stability because one buggy app can't bring down the whole server. And scalability, oh, it becomes so easy. If your website suddenly gets a ton of traffic, you just launch more identical containers. Problem solved.
But, Docker isn't a silver bullet. It's not the right tool for everything. It really wasn't designed for desktop apps that have a graphical user interface. And for a really tiny, simple project, the setup might just be overkill. Oh, and the performance on Macs? Yeah, that can be a real headache. Since Docker needs Linux to run, on a Mac it has to run inside a tiny virtual machine, and that extra layer can really slow things down.
But even with those drawbacks, the core idea here, containerization, is seen by almost everyone as a fundamental leap forward. The idea of packaging an application together with its entire environment, it just feels like the next logical step in how we build and ship software. And this kind of brings us to our final thought. Docker really solved this massive problem of making software portable and reliable. So now that we have this universal package, this magic box that can run anywhere, what does that make possible? What new doors does this open up for the future?